Hello friends, in this video we will establish few definite integral formulas that will be helpful in establishing the Fourier series of some functions. Starting from the first formula, the integral of function cos of nx dx within the range alpha to alpha plus 2 pi, this is equal to, its value is equal to 0. How we can prove this result? Simply just write the integral alpha to alpha plus 2 pi cos of nx dx. What will be the integration of cos of nx? This is our sine of nx by n within the range alpha to alpha plus 2 pi. By using fundamental theorem, you may write here this is equal to sine of upper limit alpha plus 2n pi. This is n times alpha plus 2 pi minus sine of n alpha. This is equal to 1 by, outside is 1 by n as it is. You will get it as 2n pi plus n alpha minus n alpha is there. This is equal to 2n sine of 2n pi plus theta. This is your sine theta. You may write here sine of n alpha minus sine of n alpha is there. Your final result is 0. Fine. Or second, similarly on the same track, we can prove that integral from alpha to alpha plus 2 pi sine of nx dx is also 0. On the same lines, I hope all of you are able to prove this. My third result, we can separate third result into two parts. Integral alpha to alpha plus 2 pi cos of mx into cos of nx dx. This is equal to 0 if m is not equal to n, and in case m is equal to n, then it will become what? Pi. If m is equal to n. We can prove this result. Now let's prove this result. Integral from alpha to alpha plus 2 pi cos of mx cos of nx dx. Multiply the integrand by 2 and divide the same by 2. This will become what? Cos of mx cos of nx dx. I hope all of you are able to recall the formula of 2 times cos A cos B. What is this formula? This is what? Cos of m plus n x plus cos of m minus 1 m minus n x. In case you have forgotten the formula, you can recall it. Like, see how we can recall the formula. In lower classes we did cos of a plus b is what? Cos of a plus b is cos a cos b minus sin a sin b. Similarly, we can write cos of a minus b. Cos of a minus b is cos a cos b plus sin a sin b. As we need the formula for what? 2 times cos a cos b. Do divide these two terms. On adding, what will happen? These two terms will cancel out. On adding, what you will get? Cos of a plus b plus cos of a minus b is equal to 2 times cos of a cos of b. Fine. Now let's integrate this. 1 by 2 as it is. What will be the integration of cos of integration of cos of m plus n is sine of m plus n times x divided by alpha plus 2 pi. Oh, sorry. Divided by, let me erase and write it again. This is divided by m plus n. M plus n plus integration of the next part. This is sine of m minus n divided by m minus n. Lower limit is alpha, upper limit is alpha plus 2 pi. We are working for the case when m is not equal to, here we are working for the case when m is not equal to n. See what will happen. Upper limit, this is 1 by 2, upper limit 2, alpha plus 2 pi. See, this you will get m plus n alpha plus 2 pi divided by m plus n plus sine of m minus n times alpha plus 2 pi divided by m minus n. Upper limit minus lower limit. Lower limit is alpha. You will get sine of m plus n times alpha divided by m plus n plus sine of m minus n times alpha divided by m minus n. Fine. Now on solving, see the first one, what you will get? 2m plus n pi plus m plus n times alpha. On solving this, you will get sine of m plus n times alpha by m plus n. Fine. This is m plus n plus sine of m minus n times alpha divided by m minus n. Now this minus the entire bracket m plus n times alpha divided by m plus n plus sine of m minus n times alpha by m minus n. Now if you will look at the terms, this term will cancel out with this and this will cancel out. So your net answer is 0. It's a case when m is not equal to n. Now see what will happen if m is equal to n. Case 2. If m is equal to n, you know, our integral alpha to alpha plus 2 pi cos of mx cos of nx dx, this will reduce to, if m is equal to n, you know, this will get reduced to cos of mx into cos of mx dx. Again, what we will get here? This will become alpha to alpha plus 2 pi. This is cos square mx dx. Again multiply and divide it by 2. On multiplying and dividing it by 2, I will get 2 cos square mx. Now do recall the formula. If you remember, cos of 2a is, what's the formula for cos of 2a? This is your 2 cos square a minus 1. From the same formula, I hope all of you are able to write 2 cos square a is equal to 1 plus cos of 2. If you have forgotten the formula, you can derive from this. Otherwise, we can apply the formula directly here. This is alpha to alpha plus 2 pi. I will write here 1 plus cos of 2 mx dx. Let's integrate the same. this is 1 by 2, its integration is x plus sine of 2mx by 2m from alpha to alpha plus 2 pi. This is equal to 1 by 2, upper limit is alpha plus 2 pi plus 1 by 2m sine of 2m into alpha plus 2 pi minus lower limit is alpha plus 1 by 2m sine of 2m alpha. On expanding, this alpha and this alpha will cancel out, even this term will cancel out with this term. So we will be left with 1 by 2 into 2 times pi. Pi and pi will cancel out, your result is pi. So what's our case? In case m is equal to n, if m is equal to n, what's the value of the integral? Value of the integral is pi. If m is not equal to n, value of this integral is 0. On the same lines, we can prove other results. I will write the other results and I will left the proof of other results for you. Next is, in case your integral is alpha to alpha plus 2 pi, alpha to alpha plus 2 pi sine of mx into cos of nx dx. Again, we can divide the result into two parts. It is equal to 0 if m is not equal to n, and this is also 0 if m is equal to n. Similarly, other results, alpha to alpha plus 2 pi sine of mx sine of nx dx is equal to 0 if m is not equal to n, and this is equal to pi if m is equal to n. Now, recapitulation of this. See, we are having two results where your value of the integral is equal to pi. One is sine of mx, sine of nx in case m is equal to n. And in the one of the results, if we are writing the product of cos and cos of mx and cos of nx, and if their product, if m is equal to n, then the value of this integral is also pi. These results will be helpful in expanding the given function as a Fourier series. I hope this is clear to you all. We will discuss few problems in the next video. Till then, have a good day.